Hello friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video we are going to sketch the root locus for given open loop transfer function. We are also going to understand when we have to calculate the angle of asymptote, breakaway point and angle of departure. Let us first understand what is the given open loop transfer function and then we will decide the number of poles and number of zeros. G of s h of s is equal to k s plus 1 divided by s square plus 4s plus 30. Now what is the first step? First step is to find out the number of poles, that is n, and the number of zeros, that is m. So to find out the number of poles n, we have to take denominator is equal to 0, that is s square plus 4s plus 13 is equal to 0. Now we will find out the roots. So what is the formula? So this is second order equation. So formula is minus b plus minus under root of b square minus 4ac divided by 2a. Now we will put the value. Now what is this ABC? So coefficient of s square is a, coefficient of s is b and 13 is c. If I put the value, then minus b, that is minus 4 plus minus under root of b square, that is 16 minus 4ac. So a is 1, here is 13 and here is 4, that is 52 divided by 2a. So 2a is nothing but 2. Now we will solve this with the help of calculator. Now I will take 16 minus 52. So 16 minus 52, that is minus 36, and for this minus under root of minus 36, so if I take square root, then it is square root of 36, that is 6. So I will write here which is equal to minus 4 plus minus. Now here I will write minus 36 divided by 2. So how we can solve this next? That is I will take under root of 36 multiplied by under root of minus 1, and under root of minus 1 is nothing but j. So the next step is we have to take divided by 2 also, that is 4 divided by 2, that is minus 2 plus minus. Now under root of 6 divided by 2, under root of 36, that is 6 divided by 2, that is 3, and under root of minus 1 is nothing but j. So here this minus 2 plus minus 3j is the roots for this denominator, and that means we can say that one root is minus 2 plus 3j and second root is minus 2 minus 3j. That means number of poles, two roots are there, and that is why number of poles n is equal to 2. So this is the answer, that is the number of poles n. Now we will move for the next calculation, that is number of zeros, and for the calculation of number of zeros we have to show the s term in numerator is equal to 0, that is s plus 1 is equal to 0, therefore s is equal to minus 1. So this s is equal to minus 1 is only one root, so we can say that m is equal to 1. So in this way we have find out the poles as well as zeros. Now we will plot this. So when we plot this, then only we can understand, that is when to calculate the angle of asymptote, when to calculate the breakaway point and when to calculate the angle of departure. So first if I plot 0, that is at s is equal to minus 1. So we have to take s plane, which is the combination of real axis and imaginary axis. This is the real axis and this is the imaginary axis, and point of intersection is origin O. Now on real axis, on the right hand side we have to plot the points 0, 1, 2 and so on, and on the left hand side 0, minus 1, minus 2 and so on. Now on imaginary axis we have to plot the points in terms of j, that is from 0 here is j, 2j, 3j, and from 0 here minus j, minus 2j, minus 3j. Now 0 is at s is equal to -1. So I will use here the sign for this pole, that is this sign, and for this poles I will use sign this cross sign. Now 0 is at s is equal to -1, so I will show here as a 0. Then poles, there are two poles which are at -2 plus 3j. So how to plot that? Here is -2 and plus 3j. So here is plus 3j. So with the help of this scale, if we use, we have to take this vertical line, and then that is -2 is there. So I have taken this -2, and then we have to take from imaginary axis plus 3j. So plus 3j, if I draw here one line, then this is the point of intersection. So at this point of intersection, we have to show the pole. Now in the same way, -2 minus 3j. So this is the -2 on real axis. Now we have to select here one point and minus 3j. So from minus 3j, we have to take the horizontal distance. So here is the point of intersection. So I have to show this cross. So in this way, these two poles and 1 0 is getting plotted. Now we will move for the next step. Now how many number of branches are there? So number of branches, that is equal to number of poles. That means there are total 2 branches. So we have to write here, there are total 2 branches. Then next step, we have to decide how many branches terminate to 0 and how many branches terminate to infinity. So how we can decide? So we know that the branches originates from the pole and terminates or ends at zeros, and remaining branches terminates to infinity. Now if we observe, there are total 2 branches which will originate from these 2 poles, and one branch will terminate at 0 because here only 1 0 is there. So remaining other branch will terminate to infinity. So we can say that in this question or for this graph, one branch will terminate to open loop 0 and other branch will terminate to infinity. So we have to write this. Branches originate at open loop poles and ends at open loop zeros, and remaining branches terminate to infinity. So in this question, number of branches terminate to 0 because here only 1 0. So one branch will terminate to 0. And out of 2 branches, the remaining branch, that is only 1 branch is remaining, and number of branches terminate to infinity, that is 1. Now we will move for the next step. We will find out the range of point on the real axis for which the sum of number of poles and zeros on the right hand side should equal to odd number. Now we will use here the trial and error method. Now if I take the range of points in between 0 and -1, then suppose I will take this middle point, then for this point, how many number of poles and zeros on their right hand side? So there is no any number of pole and 0. Now if I take the range of points in between -1 and -2, so I will select here one random point. Then on this point towards the right hand side, how many number of poles and zeros? So here only 1 0 is there. So if I write 1 0, then this is odd number. So we can say that here in between -1 and -2, the range in between these 2 points is the part of root locus. Now we will again move for the next, that is we will take the point in between -2 and -3. So any point in between -2 and -3 on the right hand side, how many number of poles and zeros? Now if we observe, these poles are at -2. So these 2 poles plus 1 0, that is total number or total sum is 3. So for this we can say that 2 poles and 1 0, that is this is the odd number. So the points in between -2 and -3, or range of points in between -2 and -3 is the path of root locus. So in the same way, if I move next, that is for this -3, -4, or -3 to -infinity, then all these points contains the total sum of poles and zeros, that is odd number. So we can say that what is that range? So range is from -1 to -2 and -2 to infinity. So total range is from -1 to -infinity, because here this left hand side, here the last one is we have to take infinity, that is -infinity. So what is that range of point? That is, we can say that this range is -1 to -infinity. So I will write this with the help of red marker. So this range is the part of root locus. I have shown the range of points which are the part of root locus with the help of black marker. That is, this range is in between -1 to -infinity. So we have to show this range with the help of the black marker. So all these points in between -1 to -infinity are the part of root locus. Now main important question is that when we have to calculate the angle of asymptote, when we have to calculate the breakaway point, and when we have to calculate the angle of departure. Now we know that for this given open loop transfer function, one branch that will terminate to 0 and other branch that will terminate to infinity. So whenever there is the branch that will terminate to infinity, then we have to calculate the angle of asymptote, because the branches terminate to infinity moves along the asymptote. Then the next point, when we have to calculate the breakaway point. So what is this breakaway point? So breakaway point is the location of point on this real axis from where the branches depart. Now we know that for this graph, branches will start from open loop poles. So these are the two poles from where the branches will start, and one branch will end at open loop 0 and other branch will terminate to infinity. So what is the exact location of point on this real axis from where the one branch will terminate to 0 and other branch will terminate to infinity? So we have to find out that location of the point. Then third important question, when we have to calculate the angle of departure. So for that we have to remember that there should not be any poles and zeros. Suppose there is poles and zeros not lie on the real axis and imaginary axis, and when the location of poles and zeros is symmetric about the real axis, then we have to calculate the angle of departure. Now if we observe this location of poles and zeros, only one zero lie on the real axis, but other two poles are symmetric about the real axis. So what is the meaning of that? That means upper portion from real axis and lower portion from real axis should be same. That is, the meaning is that the graph should be symmetric about the real axis, and when the location of poles and zeros not lie on the real axis and imaginary axis, then only we have to calculate the angle of departure. So for this question, because these poles are symmetric about the real axis and these poles does not lie on this real axis and imaginary axis, therefore we are going to calculate the angle of departure. So these three are most important points you have to apply for each and every question. Now we will move for the calculation of angle of asymptote. So what is the formula? Angle of asymptote 2q plus 1, 180 degree divided by n minus n, where value of q we have to take from 0, 1, 2 up to n minus m minus 1. So n is nothing but number of poles. So I will put here the value. Number of pole is 2 minus m is nothing but number of 0, that is only 1 0 is there, and then minus 1. So 2 minus 1 minus 1, that is 2 minus 2 is 0. So we have to take only q is equal to 0. So when I put q is equal to 0, then what is the answer for that angle of asymptote. So 2 multiplied by 0, that is 0, 180 degree divided by n minus m. So n is 2 and m is 1, that is 2 minus 1 1. So answer is 180 degree. So we can say that the angle of asymptote is 180 degree. So we have to show this 180 degree angle. So we know that how to take this 180 degree angle, that is from real axis we have to move from 0, 10, 90 and then 180. Now we will find out the breakaway point. So breakaway point, that is we have to first take characteristic equation. Now question is that open loop transfer function g of s h of s. So what is the characteristic equation? That is 1 plus g of s h of s. So 1 plus this equation that we have to write. So this is the characteristic equation, and from this characteristic equation we have to find out the solution dk by ds is equal to 0. dk by ds is equal to 0. When we take this solution, then from this solution there are roots, and from that roots we will define the breakaway point. So we know that the breakaway point is the location of point on real axis from where the branches depart. Now I will take here how to find out this k. So suppose 1 plus k, s plus 1 divided by s square plus 4s plus 13 is there. So we will first transfer 1 to the left hand side, then it will become minus 1, and then I will transfer denominator, so it will move to the numerator, and then I will transfer this numerator, then it will move to the denominator. So k is from this equation, k is equal to minus 1 in the bracket s square plus 4s plus 13 divided by s plus 1. Now we have to take the solution dk by ds is equal to 0. So dk by ds, that is we have to differentiate with respect to s. So this is in the form of numerator and denominator. So I will take minus sign outside the bracket and I will differentiate this numerator and denominator. So how to differentiate? We know that denominator constant we have to differentiate numerator, minus numerator constant we have to differentiate denominator, divided by we have to take the square of denominator. So here denominator constant, that is s plus 1 constant, differentiate this numerator, that is s square, that is 2s plus 4, minus now numerator constant, that is s square plus 4s plus 13, then what is the differentiation of s plus 1? That is 1, divided by s plus 1 brackets. Now we have to take dk by ds is equal to 0, that means this whole bracket which is equal to 0. Now I will transfer this minus sign to the right hand side, I will transfer this denominator to the right hand side. So what is the remaining? Remaining is numerator, so we will simplify this. S plus 1 multiplied by 2s plus 4, that is equal to 2s square plus 4s plus 2s plus 4. That means we have to multiply with these two brackets, and at the same time we have to multiply this minus side inside the bracket, that is minus s square minus 4s minus 13. So s square plus 2s minus 9 is the solution for dk by dx. Now we will find out the roots. So how to find out the roots? This is the second order equation. So we will say that we have to take minus b plus minus square root of b square minus 4ac divided by 2a. So what is this a, b, c? So here a is coefficient of a square, then b is coefficient of s, and c is this constant value. So a is equal to 1, b is equal to 2 and c is equal to minus 9. So we have to consider this sign also. So minus 2 plus minus square root of b square, that is 4 minus 4ac. So minus 4 multiplied by a multiplied by c. So minus 4 multiplied by 1 multiplied by minus 9, that is plus 36 divided by 2. So when we solve this, then we will get the answer s is equal to 2.16 and s is equal to minus 4.16. So there are two answers. So how to find out the breakaway point? So we know that the range of points that are the part of root locus. Now if we observe 2.16 is the point that is on right hand side. So this part is not on the root locus, and S is equal to minus 4.16. Now if we observe minus 4.16 is the point here. So we can say that minus 4.16, I have shown with the help of black marker, all these points are the part of root locus. So minus 4.16 is the breakaway point. Now we will move for the calculation of angle of departure. So for that we have to first select one pole as a reference pole. So I will select this pole as a reference pole minus 2 plus 2z. Now what is the formula to calculate the angle of departure? That is, angle of departure theta d is equal to 180 degree minus, in the bracket, summation of angle made by poles with respect to this reference pole minus summation of angle made by zeros with respect to this reference pole. So we will first join these open loop poles and zeros with this reference pole, and then only we can calculate the angle made by those lines. So I will join here this 0 to pole, and I will also join these two poles. Now how to calculate the angle? So I have to calculate the angle made by this pole with this 0. So for that we have to calculate the angle with respect to this horizontal line. So we have to find out this angle. In the same way, for this pole I will draw here one horizontal line, and I have to take this angle. Now if we observe, these two poles are symmetric about the real axis. So these two poles lie along one single line. So with this horizontal line, the angle made by this is 90 degree. Now we will calculate the angle made by this open loop 0 with respect to this pole. Now if I draw here one vertical line passing through this minus 1. So I will draw this line in the form of dash, because this is the construction line. So this vertical line is nothing but angle made by this vertical line with respect to this horizontal line is 90 degrees. So we have to calculate this remaining angle. So again I will draw here one line that will passing through this reference pole. So here is the point of intersection. If we observe this construction, then this is the right angle triangle, and the total angle made by this 0 with this pole is nothing but this angle 90 degree plus this angle theta. So now we have to calculate this angle theta. We will use here the formula tan of theta is equal to, so opposite side we have to take this. So from this point to this point, what is the total distance? So for this total distance we will take the difference in between these 2 points, that is minus 1 minus minus 2. So minus 1 plus 2, that is, this difference is 1 divided by. Now we have to take the height for this triangle. So it is from 0 to 3j. So this total height is 1, 2, 3. So this 3 unit. So 1 by 3. So what is the angle theta? So theta is nothing but tan inverse of 1 by 3. So we have to take here 1 divided by 3. That is 0.33, and we have to take the tan inverse for this answer is 18.43 degree. So what is the total angle made by this 0? So we have to take plus 90 degree. So plus 90 is nothing but 108.43 degree. So angle made by 0 with this pole is 108.43 degree. So we have to write this, because here there is only 1 0 is there. So for this summation we have to take only 1 0. Now what is the angle made by this pole with respect to this reference pole? So this angle is 90 degrees. So with respect to horizontal line we have to measure this angle, and it is 90 degrees. So only one pole is there. So we have to write this only one angle. So these values we have to put, then we will write here the formula. So we have to take here plus minus 180 degree. So plus minus 180 degree minus 90 minus 108.43. So if we calculate this, then we will get the answer 90 minus 108.43, that is minus 18.43, and here is also minus sign, so here plus minus 180. Then if we observe plus minus 180 plus 18.43. So now we will use here first plus sign. So 180 plus 18.43, answer is 198.43. Then we will use minus sign. So minus 180 plus 18.43. Then here minus or 161.57. So at this reference pole, either the angle is 198.43 or minus 161.57. Now with the help of protractor, we will plot the angle of departure. Now for this reference pole, if we take the angle is 198.43 degree, then for that we have to first take this horizontal line, and from this horizontal line we know that here the total angle covered is 180 degrees. So for remaining angle, again we have to select this protractor. Here center point will be the pole, and we have to take 198 minus 180. That means here we have to take 18.43 degree angle. So this 18.43 degree angle is getting covered, and we will draw here one line passing through this point. So this is nothing but the angle of departure. So I will show here this total angle is 198.43 degree. Or we can take this minus. So for this minus sign, we have to measure the angle from this downward direction. So if I take here minus 161, so from 0 to here minus 161, if we take, then here is also the angle, that is minus 161.57 degree. Now in the same way, we have to select the angle for the second pole. Now these two poles are symmetric about the real axis. So for this pole we have to just oppose the sign. That means for second pole we have to take the angles, that is for this plus 198 we have to select the angle minus 198.43, or for this minus 161 we have to take plus 161.57 degree. So again we will take here one horizontal line. So this we will take here plus 161.57. So with the help of protractor, if I put here the center with this pole, then here is the from 0 it will start, and here is 160, and then I will mark one point for 161.57. So from this selected point we have to draw here one line. Now for this line, this angle covered is 161.57 degree, or in opposite direction we can say that the angle is minus 198.43 degree. Now we will also write the breakaway point. So breakaway point is minus 4.16. So here is minus 4. So we will consider after 4 here minus 4.16. That is the breakaway point. So I will write here, this is the breakaway point. Now we will plot the angle of asymptote. So from this breakaway point we have to take the angle 180 degree. So if I put here protractor from this 0, here is 180 degree. So we have to extend this asymptote. So this is the breakaway point, here is the asymptote. Now we will complete our root locus sketch. So how to complete? So we know that these branches will start from these four poles. So and it will end, that is one branch will end at the 0 and other branch will move to the infinity along this asymptote. So for that, here we have to take the help for breakaway point, because here is the point of intersection for these branches on the real axis. So we have to select the branch, or we have to draw the branch in such a way that we have to take the branch along this angle of departure line. So these two are the lines with the help of, we have drawn with the help of angle of departure. So I will draw here. So we have to take here the point of intersection on real axis for branch, that is breakaway point, and here we have to take the second branch. So second branch also we have to extend up to this point, breakaway point. Now we will show arrow also. So in this direction this branch will move. Now with these two branch, out of these two branch, one branch will move to 0 or terminate to 0. So 0 is here at -1. So I have to show here one line and direction in this direction. So one branch will terminate to 0 and other branch will terminate to infinity along this asymptote. So asymptote is at an angle of 180 degrees. So with the help of red marker I have shown. So this other branch will terminate to infinity. So we have to show the arrow in this direction, and here is the branch that will terminate to infinity. So in this way the sketch of root locus is getting completed.